The formation of the major planets in our solar system is one of the most fascinating chapters in the story of the cosmos. Understanding how these planets built up their mass involves diving into the complex processes of accretion, gravitational forces, and material distribution that took place over billions of years. The birth of the solar system began with a giant cloud of gas and dust known as the solar nebula, which collapsed under its own gravity. This event sparked the formation of the Sun and the planets, setting the stage for the mass accumulation processes that would create the worlds we see today. When the solar nebula collapsed, the material began to spin and flatten into a disk, most of the mass concentrated at the center, where the Sun formed, but the leftover material began to clump together in various regions of the disk. The process that led to the formation of the major planets began with small particles of dust and ice coming together through collisions. These tiny particles started to form planetary embryos, which were essentially early versions of planets but on a much smaller scale. These embryos were only a few kilometers in size, but were the building blocks for the massive planets we see today. In the inner solar system, where temperatures were higher, the materials that could survive were primarily metals and silicates. This is why the inner planets Mercury, Venus, Earth, and Mars are rocky and relatively small compared to their giant counterparts. These rocky planets built up their mass primarily through planetesimal accretion, where objects of similar size collided and merged over time. Through these collisions, the rocky planets gained enough mass to form solid cores. As these cores grew, their gravitational pull increased, attracting more material and accelerating the growth process. Meanwhile, farther out in the solar system, in the colder outer regions, the planets were able to gather much larger amounts of gas and ice in addition to rock. This is where the gas giants Jupiter and Saturn came into play. These giants formed by a process called core accretion, but with a twist. In the outer solar system, the growing cores of Jupiter and Saturn were massive enough to begin attracting large amounts of hydrogen and helium, the most abundant elements in the solar nebula. As these planets grew, they became more capable of capturing the surrounding gas, leading to the formation of their thick atmospheres and massive sizes. Jupiter, for instance, started by building a solid core, just like the smaller rocky planets, but its core grew quickly enough to start attracting the surrounding hydrogen and helium gas. This allowed Jupiter to gain massive amounts of material, eventually growing to be the largest planet in the solar system. Saturn followed a similar path, though it didn't quite capture as much gas as Jupiter, resulting in a smaller, but still enormous planet. Both of these gas giants are thought to have completed their mass-building process through gravitational instability, where the accumulation of gas and material became so dense that it led to rapid gas accretion. Moving beyond Saturn, we encounter Uranus and Neptune, the ice giants. These planets also began their formation through core accretion, but because they were farther from the Sun, the gas and dust in their regions included more ice water, ammonia, and methane. This abundance of icy material led to their classification as ice giants. Their mass-building process was similar to that of Jupiter and Saturn but on a smaller scale. While these planets didn't gather as much hydrogen and helium, their icy components gave them their unique characteristics, including thick atmospheres of methane, which contribute to their distinctive blue color. One of the most interesting aspects of planetary formation is that the processes of mass accumulation didn't stop once the planets formed. The giant planets, particularly Jupiter, had a huge impact on the rest of the solar system's evolution. Their massive gravity affected the orbits of other objects, and they likely played a role in the formation of smaller bodies like asteroids and comets. Jupiter's gravitational influence may have even helped shape the asteroid belt between Mars and Jupiter, preventing material there from coalescing into a full-fledged planet. Similarly, the outer planets' gravitational fields influenced the development of objects in the Kuiper belt, a region full of icy bodies beyond Neptune. In conclusion, the process by which the major planets built up their mass is a fascinating tale of cosmic forces, time, and the intricate dance of gravity. From the rocky planets near the Sun, where small planetesimals collided and merged, to the gas giants and ice giants farther out, the accumulation of mass was driven by the growth of cores, gravitational attraction, and the availability of different materials. These processes, which occurred over billions of years, eventually resulted in the formation of the diverse planets that populate our solar system today. For students of astronomy, Understanding these planetary formation processes is key to grasping how our solar system evolved and provides insight into the formation of other planetary systems across the galaxy.